Agar dilution method is a quantitative measurement of the in vitro activity of antimicrobial agents where different concentrations, usually serial twofold dilutions, of the antimicrobial agents are used. This method aims to determine MIC or minimum inhibitory concentration, which is the lowest concentration of an antimicrobial agent that completely inhibits the visible growth of a microorganism. Preparation of antibiotic solutions. When preparing antimicrobial stock solution, do not use pharmacy stock or other clinical preparation and store the prepared stock solution as recommended by the manufacturers. Use only laboratory-grade antibiotic powder. Calculate volume, weight, and potency of antibiotics using these formula. The concentration of stock solution is 50 mg per milliliter. Prepare antibiotic solution from the stock solution using a twofold dilution method. Add 10 ml of sterile water in this tube and 5 ml of sterile water in the rest. In this video, we are preparing ampicillin. A total of 13 dilutions will be prepared, starting from 1024 micrograms per milliliter to 0.25 micrograms per milliliter. Transfer 2048 microgram from the stock solution to this tube. Then transfer 5 ml from this tube to the next. And repeat this until the last tube to make twofold dilution. These dilutions will be mixed with the agar. The antibiotic agar mixture in petri dishes should be 4 mm deep. This can be achieved by two methods. Method A. Add 2 ml of diluted antibiotic solution and 18 ml of MHA into a petri dish. Mix thoroughly and make sure that no bubbles are formed. Method B. Add 2 ml of diluted antibiotic solution into MHA tube. Mix well and pour into a plate. Make sure that no bubbles are formed. Make sure to prepare a control plate which contains only MHA. Leave the agar to solidify at room temperature and keep at 2 to 8 degrees Celsius. Pick 4 or 5 colonies with a sterile lube. Transfer to a tube containing 2 ml normal saline and mix. Adjust the density of the inoculum in the tube to 0.5 McFarland, which equals 1.5 times 10 to the 8 CFU per milliliter. Use the 0.5 McFarland adjusted inoculum within 15 minutes. In this video, we are using a 3mm pin. We need to dilute the adjusted solution using tenfold dilution. So the final concentration is 1 times 10 to the power of 7 CFU per milliliter. This can be done by transferring the 0.5 McFarland bacterial solution into a tube containing 9 milliliters normal saline. If you use a 1mm pin, you don't need to dilute the adjusted solution. Distribute the diluted solution into a 96 well microtiter plate. And use a replicator to transfer the bacteria onto the agar surface. Make sure that you inoculate the control agar first. Then start with the agar plate containing the lowest concentration. After the spots are dry, invert the plates and incubate them at 35 degrees Celsius or 37 degrees Celsius for 16 to 20 hours. Result reading. Ensure that the MIC of the reference strains are in the recommended ranges. Record the MIC result, which is the lowest concentration of an antimicrobial agent that completely inhibits the visible growth. Clinical breakpoints are used to define isolates as susceptible, intermediate, or resistant to the antimicrobials being tested. Broth elution is a method in which a suspension of bacteria is tested against varying concentrations, usually 0 to 4 dilutions, of the antimicrobial agent. Broth elution method can be performed by two methods, either in tubes containing a minimum volume of 2 ml or macro dilution method, or in smaller volume using microtiter plates or microdilution method. In this video, we'll show you only microdilution method. Mueller-Hinton broth with cation adjustment or CAMHB is recommended as the medium for susceptibility testing. In CAMHB, adjust the concentration of calcium ion to 20 to 25 milligrams per liter and magnesium ion to 10 to 12.5 milligrams per liter. In general, 450 microliters calcium chloride and 225 microliters magnesium chloride solution are added to 200 milliliters MHB. Label microtiter plate from the highest concentration to the lowest concentration of antimicrobial solution at the top of each column and also include the control in the last column. In this video, the highest concentration is 1024 micrograms per milliliter and the lowest is 0.25 micrograms per milliliter. Prepare the antimicrobial solution at double strength of the highest dilution from antibiotic stock solution. In this video, The highest concentration is 1024 micrograms per milliliter, so the concentration of double-strength antimicrobial solution prepared is 2048 micrograms per milliliter. Add 50 microliters of CAMHB using multi-channel pipette to the microtiter plate, except the first column, which is the highest concentration. Fill the first and second column with 50 microliters of double-strength antimicrobial solution. Mix suspension thoroughly and transfer 50 microliters of the suspension to the next column. Repeat this step until the lowest concentration. Make sure that you leave control. Pick 4 or 5 colonies with a sterile loop. Transfer to a tube containing 2 milliliters normal saline and mix. Adjust the density of inoculum to 0.5 McFarland. After adjusting to 0.5 McFarland, dilute the bacterial suspension by doing tenfold dilution twice to get approximately 10 to the power of 6 CFU per milliliter. This can be done by transferring the 0.5 McFarland bacterial solution into a tube containing 9 ml CAMHB. Then repeat the same step. Transfer 50 microliters of bacterial suspension into each column of microtiter plate. When 50 microliters of bacterial suspension is transferred into a microtiter plate with 50 microliter diluted antibiotic solution, the final concentration of bacterial suspension will be 5 times 10 to the power of 5 CFU per milliliter, or 5 times 10 to the power of 4 CFU per well. To prevent evaporation, seal each microtiter plate with parafilm. Incubate the plate at 35 to 37 degrees Celsius for 16 to 20 hours. Do not stack more than 4 plates. Results should be read after 16 to 20 hours of incubation. The first step of result reading is to check that the MIC values of the reference strains are in the recommended ranges as identified in the latest CLSI VET 01S standard. Then record the MIC value, which is the lowest concentration of an antimicrobial agent that inhibits visible growth of the organism in the microdilution wells. Clinical breakpoints, as described in the latest VET-01 standard, are used to define isolates as susceptible, intermediate, or resistant to the antimicrobials being tested.